Right, hi again. Going to just look at atomic structure. So before you tackle ionical covalent bonding, if you're not sure about atomic structure, you've got to go through that and be really familiar with it, because we're going to be talking about a lot about atoms and how we put them together when we talk about bonding. Okay, so let's get started. I think the basics you need to know are there are three particles within an atom. An atom is incredibly small, but we do have smaller particles than that. The particles that you need to know are the protons, the electrons, and the neutrons. Alright, okay, so our protons. What do we know about the protons? Well, an atom is like, I guess the best model or best comparison to think about is like our solar system with the sun in the middle and the planets orbiting. So our sun in our model for the atom would be the nucleus, the center of the atom. Okay, so our protons are located in the center. We call the center the nucleus of the atom. Okay, so they are also, as the name implies with the P, they are positively charged. Alright, a positive charge. So if we want to start doing a representation, that's my nucleus and that's my proton, okay, in the nucleus. Now, what do we know about the electrons? Well, the electrons are not in the nucleus. They're going to be like our planets, so they'll be orbiting our nucleus. So here we have our orbit, yeah? So our electrons are in the orbit. They sometimes call these orbits, they sometimes call them shells as well, just to confuse us, but don't be, they are the same thing, shells, and they have a charge. They have the opposite charge to the proton, so they are negatively charged, yeah? And I'm going to just represent my electron as an E minus, just a little minus to remind me it's negatively charged and it's zinging around the nucleus, yes? As the planets would orbit the sun, and the sun being the nucleus here, okay? With the protons, that leaves us our last particle. Okay, there's not many, only two places it could be, orbit or in the nucleus. Well, I think you might have guessed it's in the nucleus. Okay, and as the name suggests, I believe it's pretty easy to spot the charge on it, because neutrons, okay, so neutral charge, in other words, no charge. I haven't got time to tell you my dodgy joke about protons and neutrons going into a bar, but if you grab me at some point, I will tell you. I'm sure you won't laugh. Right, okay, so we've got your protons in the nucleus, you have your electrons orbiting, and we have our neutrons also in the nucleus, okay? So that's our first little bit of it done, dusted. Just need to learn it, I'm afraid. Hate to say it. Learn. That's what we need. Right, so how can we now apply this idea of protons, neutrons and electrons to the different elements on your periodic table? Now, every element on your periodic table, you will notice there's lots of them, 120 I think at last count. But what we've got here are, just adjust it so you can see a little bit better. Yeah, I'm making it worse, maybe a little bit better. We have numbers above and below each of our element. Our elements are made up of individual atoms. So a lithium atom is going to be made up of lithium. A lithium element is going to be made up of just lithium atoms. Lithium atoms look different to beryllium atoms, look different to boron atoms, to carbon, to nitrogen atoms. But how do we know? Okay, and this is where these numbers I just showed you tell us all the information we need to know. The periodic table in chemistry will become your best friend. I promise you that, and because you get it in the exam, it's even better news. You can use it for so many things. So let's take lithium. I think I quite like lithium atom. Let's take Li. Okay, I've got two numbers, a big number 7 and a small number 3. It doesn't matter which way they go round, they normally give you the key on the periodic table to tell you which is which. So our 3, we'll start with that one. That 3 is hugely important to us. It tells us, well, it is called the atomic number, alright? but it tells us a crucial bit of information. And again, it's something you just must learn, otherwise you can't make progress. The atomic number tells me the number, NO, of protons. So in this case, I have 3 positive protons, yes, in the nucleus. So if I was to draw my lithium atom, I'll draw my nucleus, I'm going to plonk 3 protons, 3 positive protons in there. Now I'm now going to tell you another fact. An atom has no charge. That means we have to have an equal number of electrons. So this atomic number tells me not just the proton number, but it also tells me the number of electrons. How lucky are we with this one number? It tells me I have 3 electrons negatively charged. Plus 3 minus 3 comes out to be 0. So we have an atom has no charge overall because the protons and electrons are equal. Okay, we know that they orbit. Yes. Now I'm going to do something here that may upset you, but I'll explain. We got the orbit here. Yes. We need 3 electrons in here. So we're going to put. I'm going to show my electrons as crosses. You can do them as dots as well. That's how we do it in chemistry. That's an electron. That's another electron. Now this orbit, I'm afraid, this first orbit is now full up. The first orbit can only ever hold a maximum of 2 electrons. So once you've filled up that first orbit, you've got to go on to the next orbit, and I'll explain a bit more in a moment. So that's my 3rd electron going in. 1, 2, 3. I'm happy. Now we need to know the number of neutrons now. Okay, so I'm going up to number 7. This is what the number here is hugely important. By the way, atomic number sometimes is called in the textbook the proton number because it tells us the number of protons. So it also is referred to as that. Right, let's work out our neutrons. This 7 here is the mass number of the atom. Now atoms, I said, are so small. If you want a value for it, it's 1 times 10, about 1 times 10 to the minus 14 meters. It's standard form. Come and talk to me about it to explain, but it's pretty small. 1 times 10 to the minus 4 meters. But these protons, neutrons, electrons are even smaller than that, obviously fitting into the atomic structure. The mass number, though, the mass of the atom is all in the nucleus. The protons and neutrons have a mass of sorts. The electron, we say, has negligible mass. So we do not include it in any mass calculations. So the mass number is the protons plus the neutrons. Okay? So we know that our mass number has to include the protons and the neutrons only. So if we look at that logic, if we know our mass number is 7, okay, we already know that we have 3 protons, yes? So this 7, we've got to make 7 out of the 3 protons and how many neutrons? I'm sure your maths could do that. I'm pretty sure you're going to tell me you're going to need 4 neutrons, yes? So 4 neutrons plus the 3 protons give rise to 7. 4 plus 3, 7. Yeah, that's our mass number, the mass of the nucleus. Now, if you ever forget that, there is an easier way. We can do a bit of maths on this, but I'll just quickly show you. Neutrons equals the mass number minus atomic number, which again, the mass number is 7, the atomic number is 3. It works out to be 4 neutrons. Yes? So if you ever get stuck, big number minus small number will give you number of neutrons. Okay? Easy enough. Done deal. Superb. Let's now look at this electron arrangement in a bit more detail, yes, because I think we need to talk about that and work out where these electrons are going. So, electron arrangement. I'm just going to tell you the facts. Right, the first orbit can hold a maximum of 2 electrons. The second orbit can hold a maximum of 8 electrons. The third orbit can hold a maximum of, count them up with me, there's 8 electrons there. I'll tell you where that comes from, our periodic table. You know I said how brilliant it is. Let's go across going across are called the periods, the rows. Let's count how many elements in the first row. 1, 2. Oh look, 2 electrons can be fit in the first orbit in its full. Let's go to the second row or period. How many elements do we have? 1, 2, 3, 4, 5, 6, 7, 8. Yes? Guess how many electrons we have in the next to hold the maximum number? 8. Yes? Let's go to the next orbit or the next period. 1, 2, 3, 4, 5, 6, 7, 8. 8 elements in that row. 8 electrons fill up the orbit. And if you want to know the fourth orbit or the fourth row, let's have a look. If you count across, can't be bothered, but you count. Do you count? What do you get? 18? That was 18. So that counts up to 18. So that can hold 18 electrons. So first orbit equals max of 2 electrons. Second orbit equals a max of 8 electrons. And the third orbit equals a max of 8 electrons. If you ever forget, use your periodic table. It's given to you in the exam. You can work out the number of electrons per orbit. Now, with this next little bit, it sounds like I'm talking to myself, but I'm recording. It's okay, you can come and do what you need to do. It's alright, it's okay. Right, so we've got our 8, sorry, that was just the cleaner coming in, so ignore that a little bit. So we've got our 2 electrons, 8 electrons, 8 electrons. Okay, so what we've got to do next, okay, is try to practice this and use this arrangement. Now, let's go and take, for example, let's take magnesium. So if we took magnesium, I'm going to say, because I'm a bit sad, I do know my numbers. 24 is my mass number. My atomic number for this is 12. Okay, so if you're asked to draw the atomic structure for a magnesium atom. Magnesium, we've got our nucleus. I'm hoping you remember that 12 there means 12 protons. Yes, they go in the nucleus. Because there's no charge, we have the same number of electrons. Now that's 12 electrons, right? So we need to put 12 electrons in. Remember the orbit, first orbit can hold a maximum of 2 electrons. That leaves 10 electrons. My maths is up to it. 10 electrons left over. So this can unfortunately only hold 8 electrons. That's 10 altogether now. We've got 2 more left to sort out. Well, the only place it can go is up into that third orbit. There we go. Sometimes called it shells as well. Third orbit or third shell. The electron arrangement for this one is known as 2 electrons, 8 electrons, comma 2, because there's 2 outside electrons. Just to finish off, we need to know the number of neutrons. And if you remember, the trick was 24 minus 12. I believe that's 12 neutrons. Yes? So there we go. So magnesium looks like that. Let's try another one. Let's try oxygen, because it's a bit smaller numbers. I can't be bothered to do too many more. Oxygen, 16 and 8. So you're happy, I'm hoping. We've got 8 protons, yeah, in my nucleus, and therefore I need 8 electrons orbiting. Let's have a look at that. 2 in the first orbit, you remember that? Yes? And then we've got 6 electrons left over, and that second orbit can hold up to 8. So it will happily hold 6 electrons. Yeah. So it's 2, 6 as an electron arrangement. Let's just finish off. 16 minus 8. That's 8 neutrons. Alright. Now, a few top tips to make sure you're drawing them correctly. Go back to our periodic table. How wonderful is our periodic table? How many outside electrons does magnesium have here? 2. If I go back to my periodic table and I go and find magnesium, which is here, it's in group 2. Yes? Group 2, the columns are the groups. 2 electrons, group 2. The outside number of electrons tells us the group number. Do you want to check it again? Let's have a look. See if it works. Let's look at oxygen. It's got 6 outside electrons. Guess what group it's going to be? Let's hope it's group 6. There's oxygen. And there's my group 6. Yes? Happy days. It works every time. The other amazing thing as well, look at the number of orbits for magnesium. We've got 1, 2, 3 orbits. We go back to the periodic table. Let's look at what period or row it's in. That's row 1. Lithium starts at row 2. Row 3. Hey, magnesium's there. So the row or period number tells me the number of orbits. Look, oxygen is in row 2 or period 2. It has 1, 2 orbits. Happy days. That's all good. Let's just write that down. I think that's pretty important just as checks when you do some more work on atomic structure. So group number in the periodic table equals number of outside electrons. So important to remember that fact when we talk about bonding. We'll come back to that quite a lot. And the number of orbits of an atom equals the period or row number in the periodic table, PT, yeah, abbreviating it again, being a lazy chemist. In the periodic table, group number in the periodic table equals the number of outside electrons. Number of orbits equals the period or row number in the periodic table. Try a few. Hopefully you'll work out to be exactly the same as we've done before. Refer back to the tutorial. It will help. You've got to be able to do atomic structure before you do much else in chemistry. So this is a pretty important tutorial to get to grips with. Okay, talk to you soon. Bye bye.